Thank you for that fabulous introduction. My name is James Ashley. Today, I want to talk to you about the XR framework wars. And what I mean when I talk about the framework wars is there are a lot of different platforms out there right now for doing AR, for doing VR, for doing spatial computing. And the problem that developers face when they look at all these options is everybody has their own development kit. And what you'd really like to be able to do is develop your application once and then be able to deploy it to a lot of other platforms. For instance, maybe you'll start off with the Microsoft HoloLens, and later you change your mind and decide you also want to be on Magic Leap or something else. It would be great to have that option to easily port your app over. In order to support something like that, you need a framework. And what the framework does is it allows you to program against the framework and defer the decision about where you're going to deploy it to. And currently, the three leading frameworks, especially in the spatial computing world, is the MRTK from Microsoft, the XRTK, which is an independent project and open source, and the Unity XR SDK, which is obviously built in Unity. So my name is James Ashley. I'm a lead 3D developer with a company called Vim LLC in Atlanta. And what we do is we build Magic Leap apps. Currently, we have one for the architectural world that's in the Magic Leap store. Before that, for a long time, I worked on Connect programming for advertising agencies and even wrote a book called Beginning Connect Programming, targeting that. Later, I got into HoloLens development and built a bunch of HoloLens development when it first came out, and even did a video course with a friend of mine for LinkedIn Learning called App Development for Microsoft HoloLens. So I've been in this world for a long time and have been following it and have taken all the ups and downs along the way. I want to share that experience with you to sort of help you make your own decisions about how to go about developing and planning around development for spatial, VR, and AR. So I'm breaking up this talk into several different sections. First, I want to talk about the difference between AR and VR. And if you're in this talk, you probably already know a lot about that. And I just want to put a different spin on what the differences are and how it affects choosing a framework to go into. Then I want to talk a bit about how to build a development API, which will explore the decisions that go into building a framework. And when you're using one, it helps you understand which one really fits your particular scenario. I also want to talk about how to manage the future tech development, because when you're developing on the cutting edge, which is what I think everybody in the audience is doing, it's what I've been doing for many years, things get very tricky. I want to a little deeply into the MRTK, the XRTK, and the Unity XR SDK, so that people who are unfamiliar with it can become more familiar and understand what they offer. And finally, I want to talk about the future of spatial computing. As I've been getting ready for this talk over the past 2 weeks, things have really gone crazy in the spatial computing world. So we'll talk around that just a little bit too. So first of all, the difference between AR and VR. Well, the thing about VR for me is experiential, and it's that you're always sort of shut off from the world. That may seem obvious, but when you get really into VR development, you sort of forget that. And that's the key thing. What you see on the inside is absolutely fantastic, but there's also an outside world that knows nothing about what's going on there. So in that sense, you're always putting yourself in a situation with technology where you're just really cut off, and that's key to the experience. And so one of the metaphors I like to think about when it comes to VR is when people look at somebody in VR, they're going to ask you, what are you looking at? Because they can't see it. And that's very key to how that works. This is Keanu Reeves from a movie called Johnny Mnemonic. And when I was researching this, I also found this online. And apparently you can actually buy the original mask from the movie in Johnny Mnemonic that he uses for his VR helmet. It's pretty incredible. I wish I had it. So now let's go into AR, the contrast with that. So AR is always going to be, in some sense, a shared experience in that you're communing with the people around you. If there are people in the room, you're still talking to them, you're still aware of them. And the key experiences for AR really stretch back to even Star Wars. It's the Princess Leia experience, where all these virtual digital experiences are in the real world with you. It's in a shared world. And the key metaphor for people who are in AR is people will ask you, what do you see? because they're in the same world with you. They're able to talk with you, and they're able to get into your head to a certain extent. And for me, that's really one of the big experiential differences between VR and AR. For VR, it's what are you looking at? And for AR, it's what do you see? Okay. So those key differences really affect the kind of experiences that you'll build for either VR or AR. VR tends to be really huge worlds that you explore and walk around in, and AR tends to be little experiences that sit right in front of you. There's a tendency in development to think of the contrast between VR and AR as simply that VR shuts you off, and AR is simply making that transparent. And obviously, with a lot of the newer devices, like the ones from Oculus, you can go into transparency mode, but it's not really VR. It's a weird video pass-through, and the experience is just not the same. On the other hand, for people working in spatial computing and AR, the end game is really different from what's happening in VR. In VR, you want more and more power to build bigger and bigger worlds, while in AR, you want smaller and smaller devices until you get to the point of having actual glasses that you can wear, and it's not a big deal for other people. It's innocuous, but also unlocks all this data in the world around you. And people who sort of think of one as just, a slight variation of the other, again, that somehow VR is just AR with shields up, or that AR is just VR being transparent. For me, that's a category mistake. It's misunderstanding what the key differences are and the underlying differences. Okay, moving on beyond that, let's talk about developing an API. And this is a problem that all these companies face when they come out with new hardware. Obviously, they have these C APIs that they have to build immediately in order to work with the hardware at all. But C APIs are not something that anybody enjoys or is really capable of working with. So the problem then is, how do you build an easy-to-use SDK that will actually attract developers and make them want to develop for your platform? And this is the big API problem. Now, a few years ago, I worked for a company called Orbec, which did 3D cameras. And my job was to build an API for them against processing against Unity. And so I had to play with a lot of these issues, where on the one hand, you want to show off all the power of your hardware. But on the other hand, you also want to make it easy to use. You want to make it intuitive. You don't want to give a steep learning curve for developers, because if it takes too long or it's too hard, they're just never going to learn your platform. And I learned a lot from doing that particular experience, and it changed the way I looked at other people's APIs. It taught me to respect other people's APIs a lot more, first of all, because developing an API is really, really hard. And one of the key problems that any API developer faces immediately is, do you want to make it easy to use, or do you want to make it powerful? Because the more powerful something is, the harder it is going to be to learn, right? And the easier it is to learn, the less powerful usually it's going to be. And then the second problem that API developers face is, are you going to try to make some people very, very happy? Or are you going to try to address everybody's needs, but only give sort of a May experience to all of them in order to get more reach? And this is one of the key differences between the different APIs that are currently available between the MRTK, the XRTK, and Unity. Okay. Another key thing about understanding the development of these key spatial computing platforms in particular is the platforms were always created with an understanding of what was out at the time. And for the moment, obviously Google Glass happened, and then just nothing happened for a long time. So I'm leaving it off of this chart and timeline for now. But probably the revival of that sort of AR world, mixed reality world, started with HoloLens sometime in 2016. And when the HoloLens 1 came out, they also developed a tool called the Mixed Reality Toolkit to go along with it. Following that, at the end of 2017, everybody was expecting the HoloLens to come out with a sequel that was more powerful with a bigger field of view, and that didn't happen instead. And this was a surprise for everybody. They released VR devices and also called that mixed reality, which was amazingly confusing. Following that, the next big development in spatial computing was the Magic Leap, which got released towards the end of 2018. And then since then, everybody's been waiting for the HoloLens 2. I remember, I think it was at the beginning of 2019, I actually was getting calls about buying a HoloLens 2 from Microsoft. And the weird thing about it is the devices weren't even available yet. They just were trying to position themselves and position the hardware and so on. And so now it's June of 2020. They've been releasing devices for very large orders of 100 or more and 20 or more. But it's still not generally available to individual developers, which is very frustrating. And so if you're building a platform today that's going to address all these different devices, those are the ones you have to deal with primarily. If you want to deal with mixed reality, but also support VR, then your platform has to be even broader. Your framework has to be bigger. And if you want to go beyond that, it gets more and more complicated and tricky to manage. Looking forward, we already know that Facebook has some secret projects on the books. Google has been supporting Magic Leap, but there's suspicion that they may have other things on at the same time. Apple has announced and then unannounced and then re-announced different either AR headsets or spatial computing headsets over the past several months. So we think we can expect something from them, especially since they've been making a lot of major purchases of other companies. And then there's some really cool devices coming out in the 2021 timeframe that have been kickstarted. One of them is Tilt 5, which is a sort of spatial computing table, which looks amazing. And then Unreal Light, which is supposed to do things that are similar to the Magic Leap 1. And there's a little bit of controversy around that. So looking forward into the future, there's a lot of different players in this space. And one of the problems people always don't think of immediately, but really is a big deal, is it's not enough to just come out with hardware. You also have to have a fairly decent SDK or a framework around it that makes it easy for developers to work on it. Because if you don't get developer adoption, it doesn't matter if you have nice hardware because you're not going to have anything to run on it. Okay, so one of the key things about understanding when these devices came out is it affects the frameworks that were developed around it. And for the most part, these are Unity frameworks that will run on Unity because that's the easiest gaming engine for people to develop on. Unreal is absolutely fantastic, but the learning curve has always, or at least the perception of the learning curve has always been much, much higher. So HoloLens 1 came out in 2016, and it had this toolkit around it called the HoloLens Toolkit, which was absolutely fantastic because it achieved the goal of making things very, very easy. It had pre-built controls on it, had really, really good documentation. And people became very comfortable with that, the HTK. Later on, the next year, at the end of the next year, they came out with VR devices too, and sort of folded into their overall strategy. And that shifted their frameworks a lot, where suddenly they had to come out with something called the Mixed Reality Toolkit, which would support both VR and spatial computing or AR. And that always struck everybody as a little bit weird, or it struck me as weird because it was a category mistake. It was treating both VR and mixed reality as if they're similar experiences. In so many ways, it's really difficult to port either an AR experience to VR or a VR experience to AR. It's just really different things. But this is what they did. They created a framework that would allow you to work with both of them. And then later on, in preparation for the release of the HoloLens 2, they came out with a Mixed Reality Toolkit 2, which now is going to support 3 different devices, the HoloLens 1, the HoloLens 2, and also the Windows Mixed Reality VR devices. So following that, there have been other developments. Microsoft was no longer the only player in this field. Other companies came along. One of the major ones was a company in Florida called Magic Leap, and they came out with their Lumen SDK, which is their platform around their device, which sort of harkens back to the original HoloLens toolkit in that it's super easy to use, it's intuitive, it makes a lot of sense for developers, and they have massive, massive, massive amounts of documentation and examples to teach you how to use it. I've totally loved using the Lumen SDK. So following that, as I said, we have this Mixed Reality Toolkit, Mixed Reality Toolkit 2, and 2 of the sort of community developers that worked on the Mixed Reality Toolkit 2 and actually did most of the development for a long time when Microsoft had stopped working on it for a while and opened it up to the public, were Simon Jackson and Stephen Hodgson. And if you go on GitHub and look at their contributions, you'll see they just made massive amounts of contributions to the MRTK. But their vision was always that it shouldn't just support these Microsoft devices. It should be much bigger. It should support Oculus. It should support HTC Vive. It should support Magic Leap Ones and any of these new devices that came along. So that became sort of a fork in the road for them, where for very clear reasons, Microsoft didn't want to expend energies developing for other platforms. So they sort of broke off and developed another tool called the XRTK that is going to support multiple platforms at that point. So here's a side-by-side comparison that really highlights the differences between the two. The MRTK2 supports really 3 classes of devices. The XRTK, on the other hand, supports all the original ones that MRTK does, but also supports the Magic Leap 1, also supports all the Oculus APIs that you can develop for the Oculus Quest, and is always looking for new ways to support more and more devices. And I'm going to expand it even a little bit more and add 2 more frameworks at the end. So we can talk about the Lumen SDK, which was the one that came out with the Magic Leap on its own. And that one is actually really, really fantastic. But it only supports 1 device. So it does a great job of being easy to use, but has a very narrow audience. MRTK has a slightly broader audience, but it's narrowed into just the Microsoft products. XRTK supports both and also supports Oculus development too. The main drawback to that, though, is in order to create an API that supports these devices that are way different, it tends to abstract those interfaces to the point that it becomes a lot trickier, a lot more difficult to figure out how to program for each particular device independently when you need to eke out a little more performance or do something that's very specific to how VR works as opposed to AR, say, or that really tweaks a particular feature of one hardware device. And finally, the big new development that's starting up in 2020 is Unity itself is developing sort of plugin framework that supports a huge number of devices. So again, it in turn supports everything that XRTK does, but it also, on top of that, supports devices that it's always supported, such as the Apple AR Kit, the Google AR Core, and Steam VR, OpenVR, which pretty much gives you all the current AR and VR devices that are out there. So that's kind of cool. What's interesting, though, is the way that they do it. They have a plugin system so that if you do a plugin and decide to develop for, and I need to wrap up, but if you're developing for Microsoft, say, you're basically pulling in all the original Microsoft stuff so that you can use their easy-to-use APIs. And if you're developing for the Magic Leap, you pull in all their easy-to-use APIs. Okay, so the big question is, how do you manage future tech development? Basically, it's tricky. And as a friend of mine, Vincent Guigui in France, told me, whatever choice you make a year ago, you're going to finally regret a year after. It's just the way it works when you're on the cutting edge. The best you can do is pick a direction, stick to it, and always sort of find ways out if you need to. The future of spatial computing, very quickly, it's kind of a mess right now, where Magic Leap had major layoffs about a month ago and are refocusing their efforts. HoloLens is having trouble delivering their newest product. So everything's kind of up in the air. And at the same time, we have all these new companies getting into the game with their new devices too. Thank you very much for your time. If you have questions for me, I'm ready to take them now.
Awesome. All right. Thank you so much, James, for that presentation of how everybody's kind of duking it out there. I think we have time for one question. If you don't have one that you've seen in the chat, there's a lot of great ones, but the one that popped up, someone just asked very quickly, what about MR devices with pass-through like Vario or Lynx?
That seems to be the next big thing. And ideally, they will plug into the current frameworks. If they don't, I know developers like the XRTK team is always open to targeting new devices and helping them port over. But you're totally right. In the history of AR, MR, that's a thing people don't talk about a lot, which is pass-through, where you're basically just taking a video of the room and then reprojecting it onto the eyes. There are a lot of people, there have been interviews with Magic Leap people recently who say that really seems to be the next thing because there's a very low bar for that. It's easy to get out those devices compared to the much more complex HoloLens or Magic Leap things. That's going to be pretty exciting because if that happens, it means we can bring down the prices and get mixed reality experiences into more people's eyeballs.
Awesome. And so for all the other questions that everyone else has, what's the best way to get in touch with you? Just because you had the slide, but it went away super fast. So just in case if they weren't able to catch that, how can they keep the dialogue going?
Hit me up on Twitter. I'm James Ashley there, pretty straightforward. And I'm more than happy to answer any questions people throw at me.
Awesome. All right. Well, thank you so much, James, for the presentation. Vimaec, I definitely am a big fan, and also it seems we shared the same Zoom background here, so to some degree. So thanks so much. And now I think we're going to roll on, but definitely check it out. There's a lot of frameworks that are out there, kind of duking it out, and Vimaec as well is doing a lot of interesting work in the built environment realm. So it's kind of neat to see how they're implementing this technology as well. So we're not getting any kind of messages yet. So maybe we have time for one more question. And do you see one over there in the chat? All right. So then I guess the real quick one is there any reason to MRTK over the others?
When you use one that's specific to a platform, you're going to be able to get more out of that platform. So if you target HoloLens originally, your iterations are going to go faster and your creativity is going to be better because you can draw direct samples from Microsoft and adapt them. In general, unless you have big plans at the start, targeting one platform right away is going to help your development a lot because you're going to be able to do a lot more with it. And as I said, use the examples, get more fresh ideas that target the unique abilities of each device.
Mm-hmm. And then just a question I'm curious about as well, and this kind of came up. Someone said, what would you recommend when you need HoloLens and mobile viewer? But that a lot of these applications now are having like that companion app for mobile. And I guess I'm just curious, have you had a chance to kind of test that out? And what are some things that you found as far as having kind of that companion app type experience?
The companion apps are great. Magic Leap does that, and then the HoloLens also. And they tend to target iOS. Definitely look at it. There are additional SDKs for doing that. They're unique to each platform. But they create a different dimension to the whole experience. That's amazing.
Awesome. All right. Well, thank you again so much. Everyone knows how to get in touch with you. And we'll see you in reality. So a big round of applause, everyone, virtual, wherever you are. Drop those emojis, things like that for the gentleman here. And we'll be moving on to our next presenter.